Okie doke. We have finished with chapter 5. The last thing that is on this test 3 is a little bit of stuff. One section of chapter 2 we're going to go back and pick up, and then 3 sections of chapter 7. The section from chapter 2 that we're going to go back to is a section on circles, and I really don't understand why it's put in chapter 2. Chapter 7 is titled Conic Sections, and a circle is one of the 4 conic sections we're going to talk about. So chapter 7, we're going to cover circles, more about parabolas, hyperbolas, and ellipses. Those are the 4 conic sections that you're just going to be graphing, like a graphing whiz by, what's today? Today's Wednesday? By next Wednesday, you'll be graphing all these things fabulously. Conic sections happen. I want that on a bumper sticker. Conic sections happen. In real life, many things can be modeled by a conic section. For example, the Earth travels around the sun and in an elliptical orbit. It's not a perfect circle, it's an ellipse. There are a lot of flowers whose petals spread out from the middle in an elliptical pattern. Meteorologists use hyperbolas to locate lightning strike, where lightning strikes. So there are a lot of applications of conic sections, and we're barely going to scratch the surface of them. First, we need to talk about what is a conic section. Well, there's a good illustration in your book that I'm just going to put up here and point to. The word conic comes from the idea that all conic sections are formed by the intersection of a cone and a plane. When I say the intersection of a cone and a plane, you can think about one of those orange traffic cones and a sheet of paper. If you could slide a piece of paper through one of those orange traffic cones, depending on at what angle you put the piece of paper through the cone, your different conic sections would be formed. If you slid the piece of paper through the cone in the way that it was parallel to the ground, the paper was parallel to the ground, and then you took this piece of cone that you just cut off and look at the end of it, it's a circle. All right, the cross section of that cone would be a circle. However, if you slid the piece of paper through the cone at an angle so that it went in one side of the cone and out the other, but not parallel to the ground, if you picked that cone up and looked at the cross section would be an ellipse. If you took a sheet of paper, slid it through a cone in a way that it went in one side and came out the bottom instead of coming out the other side, then that cross section would be a hyperbola. I'm sorry, a parabola. Said the wrong thing, a parabola. And then if you stuck 2 cones nose to nose and slid the sheet of paper through the cones in such a way that it went in the bottom of one cone and out, or in the top of one cone and out the bottom of the other, then this looks like a pair of parabolas, but it's actually not. This is a hyperbola. A hyperbola does look like a pair of parabolas, but it has a whole different set of properties. All right, so those are the 4 conic sections that we're going to be talking about, and I have made you the most wonderful notes ever for talking about these conic sections. The first one that we're going to talk about is circles, and that's going back to 2.4. But first, we need to talk about this one tool called completing the square. We're going to use completing the square for all these conic sections to get an equation that's in general form into a more usable form. For circles, we want our equations to be in the form that we can just look at it and see the radius in the center. That's the important thing to know about a circle. So if a circle is given to us in this form, we have to manipulate it in some legal way to get it to look like this so that we can see the center and the radius. The tool that we're going to use to get general form to standard form is called completing the square. And here's your big important note about completing the square. To complete the square of the expression x squared plus bx, Notice that the x squared has a coefficient of 1 and the x has a coefficient of something else. To complete the square means to make that into a perfect square trinomial. Remember, a perfect square trinomial is the expression that you factor into one parentheses with the square outside. So it's going to look like this. That's what we want. How do we make this into a perfect square trinomial? Well, the answer is by completing the square. And the way that you complete the square is take half of that coefficient b and square it. If that was x squared plus 6x, you'd say half of 6 is 3, and then you'd square it and get 9. Adding 9 to that expression would give you a perfect square trinomial. Now, that doesn't have to make sense yet. It'll make sense in just a minute. Let's do one example. This is an expression or in this form, x squared plus something x squared plus 12x. If I just said, make that into a perfect square trinomial, then you would complete the square. You take half of 12, which is 6, and you square it and get 36. 36 is what you would have to add to that expression to make it a perfect square trinomial. And once it is a perfect square trinomial, to factor it, you remember what the factorization of a perfect square trinomial looks like. It's that one parenthesis with the square outside. And inside that parenthesis is the square root of the first term, which is x, the square root of the last term, which is 6, and where do you get the sign? From the sign of the middle term. So if this had been x squared minus 12x plus 36, it would have factored into x minus 6 squared. To complete the square, yes, but that's just one little step that we're going to do in the rest of these problems. All right? This has nothing to do with circles, parabolas, hyperbolas. This is just a tool in a toolbox. You have a math toolbox that includes the quadratic formula and many other things. Well, now it includes the tool completing the square. And you can tell that if I have an expression that looks like this, that kind of looks like this, I want to be able to factor it into something that looks like this so that I can pick out the information I need to from that equation.
But how can you add 36 without changing b?
Value of the expression. I just finished the sentence for you. You can't. I did change the value of that expression. But if this were an equation, let's say I had x squared plus 36 equals 0. You're right, I can't just add 36 without changing the value of that expression, but if I have an equation, I can add 36 to both sides. So that's what's coming up. When we complete the square on the left-hand side of an equation, we are going to have to add the same thing to the other side of the equation, or we have changed the value of that expression. All right, let's talk about circles. The two important things that you have to know about a circle in order to graph it are the center and the radius. The radius is the distance from the center to any point on the perimeter of the circle, and then the center is the point that's equal distance from every point on the circle. That's the two things we need to be able to determine to graph the circle. Well, in this form, which your book calls standard form of the equation of a circle, but I liked it better when books called it center radius form, because that's the form that you can just look at it and extract the center and the radius that you need to graph the equation. This should look kind of familiar to you. Let me think, why should it look familiar to you? Well, we've just talked about horizontal and vertical shifts, where H was your horizontal shift and K was your vertical shift. And we said to get that horizontal shift, it always works the opposite of what you expect it to. So you take the opposite of the guy in parentheses. That's been our non-technically correct way to tell you how to find that horizontal shift. Here, if you take the opposite of both guys in parentheses, the positive H and the positive K, that's the center of your circle. And when you have an equation in this form, standard form or center radius form, the radius of the circle is just the square root of that number on the right-hand side. So if we had blah, blah, blah equals 49, then the radius of that circle would be 7. And the center is going to be the opposite of both guys in parentheses. Now, what you're going to notice today and Monday is we're going to have a lot of equations. We have two equations for a circle. We have 2 equations for a parabola. On the next page, we have equations for ellipses and equations for hyperbolas. That's going to be an awful lot to memorize, except for you don't have to memorize it. You just have to know what the equation looks like, and that's what I've highlighted in gray for you. To recognize the equation of a circle, both variables just have to be squared with the same positive coefficient. If you have a 2x squared and a 2y squared, it's a circle. If you have a 2x squared and a 5y squared, it's not a circle. To identify a circle, both variables have to be squared with the same positive coefficient. If that equation is given to me in center radius form or standard form, I can just look at it and see the center and the radius. If it's given to me in general form, then I'm going to have to manipulate that into the form where I can see the center and the radius. And that manipulation is going to be using this new tool, completing the square. Now, I know when I just talk, and don't write down anything, your brain tends to wander and it doesn't make sense till you see an example anyway. So let's talk about these examples. Number 6 from page 186 says, true or false, the center of this circle, x plus 3 squared plus y minus 2 squared, is 13. How did I tell you to find the center of a circle that's given to you in standard form? Opposite of both guys in parentheses. So what is the center of this circle? -3, +2. That's not +3, -2. So that's false. And you can make another note to yourself. The center is actually -3, +2. Make sure when you have that equation in standard form and you're looking for the center, you take the opposite of both guys in parentheses. All right. Number 22 through 32 all give us an equation of a circle and say, find the center and the radius of the circle and graph the circle. Now, number 22, the first thing I notice is it doesn't have 2 guys in parentheses. There's nothing that's added or subtracted to or from the x before it's squared. What does that mean the horizontal shift is? 0. It just isn't shifted to the left or to the right. It's only shifted down 1. And we didn't start by drawing the simplest circle. The simplest circle just has center at the origin. So you would start at the origin, you wouldn't move left or right, you would just move down 1, and that's the new center of your circle. You could even write it this way if it helped you see the center better. You don't have to write it this way. But certainly you could put x minus 0 in parentheses, and that hasn't changed the value of that left-hand side at all. So what's the center of this circle? 0, +1, and the radius is the square root of the constant on the other side. So the radius of this circle is, which is just 1. That equation was already in standard form. I didn't have to do anything to see the center and the radius. I just need to graph it. There's the center at 0, 1. Plot the center first and then count out the radius left and right and up and down. Up 1, you have a point. Down 1, you have a point. Left 1, you have a point. Right 1, you have a point. And those 4 points are on the circumference of the circle. Miss Courtney, what made you frown about that? Do you understand how I got those 4 points, or do you need to finish writing and let me say it again? Okay. Right. The definition. Exactly. The definition of a circle is all the points that are the same distance from the center. Well, it's easier to go left and right one and up and down one than it is to measure diagonally one. So we always get points on the left and the right of the center and above and below the center, and then just connect those points, although there are infinitely many points on that circle. All right. Any questions about 22? It's only one tiny difference in number 24, and it's not quite in center radius form. It's almost center radius form, but notice center radius form here, the coefficients, the numbers in front of both parentheses is just what? 1. Both of those have coefficients of 1, and in number 24 we have coefficients of 3. How could we get rid of those coefficients of 3 legally? That would actually be illegal. Let me show you why that would be illegal. If you had, let's say, 3 times x plus 1 squared, what does the order of operations say that you have to do first? Exponent before the multiplication, so you'd have to multiply x plus 1 times x plus 1 before you could distribute the 3. All right, so we're not going to do that. What's another way I could get rid of those 3's? Yeah, just distribute the 3, I think is what Kevin was saying, and that's illegal. You could divide both sides by 3. How many terms does that equation have? Yeah, 3. It has 2 on the left-hand side. Anything that's held together by multiplication is all part of the same term. So 2 terms on the left, 1 term on the right. I just need to divide all 3 terms by 3.
But what about your power? Wouldn't that counteract the division? The thing is how you apply it.
Tell me this, Caleb, if I had 2 times 3, let's say I had 2 to the 4th times 3 over 3, could I cancel those 3's? And they don't have anything to do with that exponent? This is the same thing. I'm just canceling a common factor. Doesn't have anything to do with the other factor. So that would leave me x plus 1 squared plus y minus 1 squared equals 2. Now that's in center radius form. Now I can just look at it and tell you the center of that circle is what? Make sure you take the opposite of both guys in parentheses, -1, +1. And what's the radius of that circle? Yeah, it's the square root of what's ever on the right-hand side, and that doesn't happen to be a perfect square. So I would either just have to leave it under a radical or get a decimal approximation. I need a decimal approximation because I don't think if I'm trying to go up square root of 2, down square root of 2, I need a decimal approximation to figure out what that is. It's about 1.4. Isn't it, somebody? Yeah, darn close to 1.5. So we're going to go up about 1.5, down about 1.5, left about 1.5, right about 1.5 from the center, and that's what we have to plot first. I'm not sure how the problems are worded in momentum. I think it asks you for the exact radius, and you would have to type in square root of 2. Now, honestly, I haven't looked at that homework in a little while, but I think there's a button. You remember how you drew a line in Momentum? You had to click the line and then click one point and drag to the other point. For a circle, you have to click the circle icon and then click the center and drag it out as wide as it's supposed to be. It'll be easy to figure out once you see it. But if it just says what's the radius, you put in the exact radius, square root of 2, and then just use your 1.4 when you're graphing. Let's see, there's the center. I want to go left about 1.5, right about 1.5, up about 1.5, and down about 1.5. And I can tell that's not going to be a perfect circle. I think I had that tick mark too low. Not going to be a perfect circle anyway because I'm not a perfect artist. Any questions about that graph? All right. Keep in mind the way that you're going to identify a circle. There's a reason I grayed that out. Because when it's easy to graph 10 circles in a row and then 10 parabolas in a row and then 10 hyperbolas in a row, what's difficult is when they're mixed together and you have to look at it and go, what kind of conic section is this? Well, you're going to learn all the stuff that's in gray on these 2 pages. If both variables are squared with the same positive coefficient, I want to be technically precise here, so I'm going to say it's probably a circle, and I'll show you in a minute how it could possibly have both variables squared with the same positive coefficient and yet not be a circle. There is an exception, but we're not going to deal with that right this minute. All right. Good? Okay. Let's go on to 28 and 32. If these problems were mixed in on the test with all the different kind of conic sections, and the first thing I had to do was identify it, what will identify that as a circle for me? Both variables are squared. We have an x squared and a y squared, and what else? Both have the same positive coefficient. Both have a positive coefficient of what? 1. So that's how I would identify it. And on the test, you would get a couple points just for drawing a circle, even if you had it in the wrong place. If you draw an ellipse for that, or a hyperbola for that, it's just -5. But if you have a circle, you got a couple points. Now you have to figure out where the center and radius are. Well, it doesn't look like this form at all. That's not in standard form. That's in general form. General form is just standard form with everything multiplied out and like terms combined. If you FOIL that, combined all the like terms, you would get general form set equal to 0. And that's what this is. So the tool we're going to use for getting something in general form to look like this is the new tool we just put in your toolbox, completing the square. And I've typed step by step what we're going to do so that when you get home and look at your notes tonight, which I'm certain you're going to do, you'll know exactly what we did in each step. In the first step, group your X's and group your Y's. And go ahead and subtract 9 from both sides. X squared minus 6x grouped together. Leave some room inside that parentheses, and you'll see why in just a minute. There's my x's grouped together, my y's grouped together. Leave some room inside that parentheses, and then subtract 9 from both sides. That's what I've done. I've grouped my x's, I've grouped my 9's, I subtracted 9 from both sides. Now I'm ready to complete the square of the x's and the y's by taking half of the coefficient of the x and squaring it. Half of 6 is 3. 3 squared is 9. But like Caleb said a while ago, I can't just go around adding 9's because I want them there, except for this is an equation, and I can add a 9 on the left as long as I'm sure to also add a 9 on the right. Then I really haven't changed the value of the equation. What about the y terms? Complete the square on the y's. I'm sorry, what? No, you only have to do to the left side what you did to the right side. You don't have to add 9 to every parentheses. It's just add 9 to the left, add 9 to the right. How about completing the square on the y's? Half of 2 is 1. 1 squared is 1. So if I add 1 to the left, I just have to make sure and add 1 to the right. Now what we've created is two perfect square trinomials. What does this first trinomial factor into? Yep, square root of the first term, square root of the last term, sine of the middle term. What does that second perfect square trinomial factor into? Y plus 1 squared. Good. What does that right-hand side clean up to be? Just 1. We have magically transformed an equation that was in general form, to an equation that's now in standard form or center radius form. You can just look at that now and tell me that the center is what? 3, negative 1. You remember to take the opposite of both guys in parentheses. And the radius is what? Square root of 1 is 1. So there was more work to number 28 just because it wasn't given to us in the form that we could automatically see the center. We could identify it without doing any work, but we had to work to find the center and the radius. And then we could graph it. Center is 3, negative 1. From that center, go up 1, down 1, left 1, right 1. And do your best to draw a nice uniform circle. Have some days that are better at circles than others. This so far looks like a good circle day. Casey, how about that? So far, so good? All right. Now, number 32 is only one step harder, and it's one step harder for the same reason that 24 was a little bit harder than 22. The reason 24 was harder than 22 is 22 already had the coefficients of x squared and y squared being 1. Number 24, we had to divide in order to get those coefficients to be 1. So look at 32. If that is mixed together with every other kind of conic section on the planet, how can I be 90% sure that it's a circle? How do I identify a circle? Both variables are squared. Same positive coefficient. Now, you need those words in your head, because when these four kinds are mixed together, you're going to have to use those words to identify. If this was a 2x squared and a 3y squared, it wouldn't be a circle. Or if this was a 2x squared and a negative 2y squared, it wouldn't be a circle. Both variables have to be squared with the same positive coefficient. So it's a circle, but it's not in the form that we can look at it and see the center and the radius. Here's what we're going to have to do. Group the x's, group the y's, subtract 7 from both sides, just like we did in the first step of number 28. Group the x's, group the y's, and subtract 7 from both sides. But the reason 32 has one step more than 28 did is 28 already had the coefficients of the x square and y square being 1. 32, we have to do something to get those coefficients to be 1. Well, I could factor a 2 out of this group and factor a 2 out of that group. Now it kind of looks like number 24 in that I have that coefficient outside the parentheses that I need to get rid of. How can I get rid of those coefficients of 2? Just divide every term by 2. Divide both sides by 2. And that gives you x squared plus 4x plus y squared plus 2y equals negative 7/2. Now that I have x squared and y squared both having a coefficient of 1, I'm ready to complete the square. What would I have to add to x squared plus 4x to complete the square? Half of 4 is 2. 2 squared is 4. And if I add 4 to the right, I better make sure I do what? Oops, I said the wrong thing. If I add 4 to the left, I have to be sure to add 4 to the right. Now complete the square on my y's. Y squared plus 2y. What would I have to add to make that a perfect square trinomial? Half of 2 is 1. 1 squared is 1. If I add 1 to the left, I have to be sure to add 1 to the right. Now I've created 2 perfect square trinomials. What does this first perfect square trinomial factor into? X plus 2 squared. And the second perfect square trinomial? Y plus 1 squared. That right-hand side is negative 3.5 plus 4 is a half, and a half plus 1 is 1.5. Or, if you write it as a fraction, 3 over 2. You could punch that on the calculator if you needed to. So what is the center of this circle? Negative 2, negative 1, opposite of both guys in parentheses, and the radius? Not 1.5, but square root of. square root of 1.5 or square root of 3/2. Now, because you're doing this in momentum, or not momentum, but my math lab, every once in a while my math lab is picky, just rarely, not often. Math teachers and math labs don't leave a fraction under a radical. So my math lab could possibly count that wrong. Do you remember how to take care of a fraction under a radical? Way back in chapter R, we learned to rationalize the denominator by multiplying that fraction by whatever would make the denominator a perfect square. Because now that's square root of 6 over square root of 4, but the square root of 4 is just 2. So my math lab actually might count square root of 3/2 wrong and square root of 6 over 2 right. To graph it, I'm going to have a decimal. I don't know, square root of 6 over 2 is probably 1 point something something. Somebody get me a decimal approximation of that. Okay, so as well as I could do graphing probably to the nearest tenth, it's about 1.2. Is that what you said? That would surprise me even more, but I'd be happy if it does. I'm just telling you what to do if you're pretty sure you have the right answer and my math lab is telling you it's wrong. Before you click the instructor button, which you're welcome to do, but before you do, check and see if you have left a radical under a fraction under a radical. And if you have, rationalize that denominator, try again, and if you still miss it, click the Ask Instructor button.
So, how do you rationalize it? Just get the denominator into the perfect fraction?
Square. Yes. Remember, way back in chapter R, if I wanted to rationalize 1 over square root of 5, I would just multiply it by square root of 5 over square root of 5 to get whatever it takes to make the denominator a perfect square. That's the square root of 25, and the square root of 25 is just 5. So that's how, quick review of how to rationalize a denominator. All right. Those are all the examples that we're going to do for circles. They were in ascending order of difficulty. One that was already in center radius form so that you could just look at it and see the center and the radius. One that was almost in center radius form. You just had to get rid of the worrisome coefficient. And then 2 that you actually had to complete the square to get it in center radius form. So, section 7.2 is parabolas. We're going to talk about circles and parabolas today, ellipses and hyperbolas Monday. And then it's not very long until the test. Let me see. Yeah, test is next Wednesday. That's why at the bottom of this page it says start on practice test 3. After today, you can do everything on test 3 except for graphing, ellipses, and hyperbolas. So you need to work on it this weekend. I'm sorry, Miss Courtney. I know you had a hot date. Not really. Okay, parabolas. We've already talked about parabolas and what kind of equation gives us a parabola. What kind of equation does give us that nice, smooth, U-shaped curve? It has an x square in it. You could call that second degree, but the big official math word is, what kind of equation has a quadratic? You are the none of the day. Yes, a quadratic equation gives us a parabola. Now, all that we've talked about so far is parabolas that either were concave up or concave down. If we have a concave up or concave down parabola in any of those examples, you can already do it. But there are also parabolas which are, you don't call it concave left, but open to the left or open to the right. So the first thing we need to do, I guess first thing we need to do is learn how to distinguish parabolas from circles. Parabolas are the only conic section that only has one variable squared. So if you look at the equation and only one variable is squared, it's a parabola. I just thought of something I didn't remember to go back to with circles. I said that if both variables are squared with the same positive coefficient, you can be 90% sure it's a circle. What else could happen? What if I had this equation and it equals something on the right-hand side and I completed the square and I worked and I got it in this form, but the right-hand side cleaned up to be 0. Let's see, if the right-hand side cleaned up to be 0, the center would still be 3, -1, but what would the radius be? Square root of 0 is 0. How do you graph that? What is a circle with center something something and radius 0? It's just a point. You would graph the center, but then you would count up 0, down 0, left 0, and right 0. The whole graph is just a point. So that's one exception. You do have to see what the radius turns out to be, and if the radius is 0, that means you have just a point. And then the other thing that could happen, what if I worked and I got it in what looked like center radius form, but I ended up with a negative on the right-hand side? Let's say instead of a +1, this was a -1. The center would still be 0, 1, but what would the radius be if that was a -1? It would be an imaginary number. Specifically, if that was -1, the square root of -1 is what? Just I. So how do you graph a circle that has center 0, 1 and an imaginary radius? That's the thing that nerds just sit around and try to imagine, like me. Sit around and, I kind of think of a vortex or an any belly button. Something, yeah, it just imploded on itself. I don't know. I'm sure Stephen Hawking knows, but I don't know. For me, I'm just going to say if r squared is less than 0, that means there's an imaginary radius. And there is no graph in the Cartesian coordinate system. Assignment 16, not tonight's homework, but the next night's homework, you actually print it out in Momentum and do it on paper and turn it in to me. It has some problems that just say identify. You don't have to graph them. You just have to identify, but the choices are going to be circle, parabola, hyperbola, ellipse, point, or no graph. And now you know what gives you point or no graph. It looks like a circle, but the radius is 0, then it's a point. It looks like a circle, but the radius is imaginary, it's no graph. Everything else, if it looks like a parabola, it's a parabola. If it looks like an ellipse, it's an ellipse. Same thing for hyperbola. Okay, so let's go back to our parabolas. I just had to tell you about the no graph and the point. A parabola that opens up or down has a vertical axis of symmetry. Remember, we talked about the axis of symmetry as the vertical line that goes through the vertex. So A parabola that opens up or down has a vertical axis. A parabola that opens left or right has a horizontal axis. Well, the way that you're going to identify that it's a parabola to begin with is only one variable is squared. Which variable is squared tells you whether it has a vertical axis or a horizontal axis. And here's all you have to think about. Have you ever seen that equation before? Y equals a times x minus h squared plus k? Yeah, I can just look at that and tell you the vertex is hk. That's vertex form of a parabola. Y equals x squared is what we've been graphing for weeks. So it's the up or down depending on whether a is positive or negative. The one that looks like we've always been doing, the x squared, has a vertical axis. If the y is squared, we haven't seen one of those before. We have not graphed x equals y squared because it's a parabola with a horizontal axis. All right, 37 through 51. We may actually be able to get them all done in 28 minutes. If I could get this sneeze over with. That's gonna be great on videotape when it happens. Okay, it may be gone. Number 37. Number 1, how do I know that cannot possibly be a circle? Only one variable is squared. That's the first thing I notice. If all these problems are mixed together, it can't be a circle because only one variable is squared. As a matter of fact, that tells me what it is. There's only one conic section that only has one variable squared, and it's a parabola. So I know this is a parabola. Now I need to figure out if it's a uppy-downy or if it's a lefty-righty. That sounds great on a video too. Is it the kind of parabola I've been graphing? What I've been graphing is y equals x squared. The x is squared. Is that what 37 is? The x is squared. I mean, it's written with the y on the right-hand side, but still it's the x that's squared. So it is a parabola with a vertical axis because the x is squared. When the y is squared, it's going to be a parabola with a horizontal axis. If all you ask me to do is identify it, that's the answer. It's a parabola. If you want me to graph it, then I need the first degree term by itself. Now, what do I mean by that? Which variable is the first degree term? The y to the first? I don't mean the first degree term by itself. I mean the first degree variable by itself. How would you get that y completely by itself? Divide both sides by 4. You could either write that as x squared over 4, or you could just write 1/4 x squared. We're more accustomed to seeing the y on the left, so I turned it around, but really you don't have to. What is the vertex of that parabola? You could do this in section 4.3. What's the vertex of that parabola? Is there a horizontal shift inside the parentheses before the x is squared? No. Is there a vertical shift added or subtracted on the end? No. So what's the vertex? Still 0, 0. And is that parabola concave up or concave down? because the leading coefficient is positive. All that 1/4 affects is the width of the parabola, and we're not trying to be really precise here. When I want you to be really precise, you'll know it. I'll give you a part A, B, C, D, E, F, G, ask you for the x-intercept, the y-intercept, the axis, and unless I ask you for all those details, all you really have to do is say, hey, that's a concave up parabola with vertex at the origin. Because there is no horizontal or vertical shift. What about 38? Why is it definitely not a circle? Only one variable is squared. My folks who are talking out loud to me, this is going to get stuck in your head and you'll remember it when you need it. I actually go home and say these things to myself at night to make sure I don't forget. If only one variable is squared, it's a parabola. And here it's the y that's squared. Is that what we're used to, x equals y squared? No, we're used to y equals x squared. That opens up or down. X equals y squared is going to open left or right. That's going to have a horizontal axis because the y is squared. I'm going to get you to add one note right there that may be helpful tonight. Solve for the first degree variable. That's what we did in number 37. We got the y to the first by itself. So in 38, we want to get the x to the first by itself. What would we have? 1/8 y squared equals x. Or if it bothers me written in that order, I could turn it around to x equals 1/8 y squared. What is the vertex of that parabola? It still doesn't have a horizontal shift or a vertical shift, so its vertex is 0, 0. Just take a wild guess whether you think it's going to open to the left or to the right. What makes you say that? Kind of just makes sense. If a parabola with a vertical axis opens up because of a positive coefficient, then a parabola with a horizontal shift is going to open to the right because of a positive coefficient. If that was a negative coefficient, it would open to the left. Again, the 1/8 affects the width, but I'm not terribly concerned about the width. If you just have a sideways parabola opening to the right with vertex 0, 0, that's good enough. What about 39? Why can it not possibly be a circle? Only one variable is squared. As a matter of fact, that means all it can be is a parabola. Is it the kind of parabola I'm used to or the new kind? This is x equals y squared. That's not what I graphed in 4.3. So it has a horizontal axis. because of the y squared. What do I need to do? Solve for the first degree variable, get the x to the first by itself by dividing both sides by negative 36. Ooh, this is a good question for your math tutor training. What about somebody that says, well, the 36 is negative, so I need to add 36 to both sides? What would you say? You're fired. How can you explain to somebody why that negative doesn't mean that you should add?
Because you're dividing them.
This is held together by multiplication. You don't unmultiply by adding, you unmultiply by dividing. So divide both sides by negative 36. You all already knew that, but like I said, I'm trying to turn you all into great tutors someday. Miss Berry would appreciate that. We have the first degree variable by itself. If we're OCD, we could turn it around. If we're not, we don't have to. I can already look at it and tell you that the center is 0, 0, because you don't have anything added or subtracted from the y before it's squared or anything added or subtracted from the y after it's squared. So the vertex is 0, 0. In what direction does it open? The negative direction would be to the left. So if you just gave me a parabola with vertex 0, 0 that opened to the left, I would be more than delighted. All right, we're still in the pretty easy ones. Number 40, can't be a circle because only one variable is squared. It has to be a parabola because only one variable is squared. All right, that's how you recognize a parabola. If on the test you have that equation and you draw a circle, it's just wrong. I don't care where the center is. It's wrong. That's not a circle. It's a parabola. Does it open horizontally or vertically? Y equals x squared is what we learned to graph in 4.3. It opens vertically or has a vertical axis because the x is squared. Now what? Solve for the first degree variable, get that y by itself by dividing both sides by negative 4. What is the vertex of this parabola? 0, 0, doesn't have a horizontal or a vertical shift. And how does it open? Down. So as long as you give me a parabola with vertex 0, 0 that opens down, that's good enough. All four of those, the reason I said they were pretty easy was the vertex was 0, 0. What if the vertex is not 0, 0? Such as 42. If all I ask you to do was identify that conic section, why can it not possibly be a circle? Only one variable is squared. Therefore, it has to be a parabola. Yeah, that's another reason it couldn't be a circle. So it's a parabola. Which variable is squared? If you fold out that left-hand side, the x is squared, so does it open vertically or horizontally? That's the kind we've been graphing. It opens vertically. Then what?
Go ahead, square x plus 4 and multiply by 16.
When I think about what the equation has to look like in order for it to be in vertex form or for me to see the vertex, I gotta have those parentheses, the guy in parentheses with the square outside. So I don't think I'm gonna mess with this x plus 4 squared. There are two things I could do. I could either distribute the 16, or what's another way to move the 16? Divide by 16 for reasons you'll see in just a minute. Let's just divide both sides by 16. Or I could even write that left-hand side as 1/16 times x plus 4 squared. What's the only other thing I would have to do to have the y completely by itself? Subtract 2 from both sides, and I have solved for the first degree variable. Maybe I am OCD because that's really bugging me. I can just see it much better if I write it y equals 1/16 times x plus 4 squared minus 2. What's the vertex of that parabola? -4, -2, opposite of the guy in parentheses and the guy on the end. And what is the concavity of this parabola? We already knew it opened vertically, and now we know in what direction. That leading coefficient's positive, so it's concave up. The 1/16 affects the width, but I don't really care about that. If you graph a circle with vertex -4, -2, I did say circle, didn't I? Oh, that was terrible. I'm sorry. If you graph a parabola with vertex -4, -2, and concave up, unless I ask you what are the x-intercepts, what is the y-intercept, blah, 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 that's good enough. All right, 44. We need to get these last three done. It's a parabola because only one variable is squared, but the y is squared instead of the x. So what does that mean? Horizontal. It either opens to the left or to the right. It's a parabola with horizontal axis, and we need to solve for the first degree variable. We could either distribute the -4, or like we did in 42, we could divide both sides by -4. We could just write that left-hand side as -1/4 times y plus 1 squared. And then if we had already divided by -4, all we'd have to do to get the x by itself is add 2 to both sides. And if it bothers you all in that order, you can write it as x equals -1/4 y plus 1 squared plus 2. What's the vertex? Most common wrong answer. There's a curveball here, and you have to watch out for it, pay attention to it. because it's going to happen with ellipses and hyperbolas as well. You still take the opposite of the guy in parentheses, but if it is with your y, it's the y coordinate of your vertex. So instead of being -1, 2, the vertex is actually 2, -1. If the -1 is with the y, then it's the y coordinate.
So the +2 is the x-intercept.
The x-coordinate of the vertex. It's not the x-intercept because y is not 0, but it's the x-coordinate of the vertex.
Sorry, I was y equals x.
Oh, that's a line. We're not even in linear equations. All right, so watch out for that. If you're in a habit of saying the opposite of the guy in parentheses and the guy on the end, and you still can, but you have to notice which guy is inside parentheses. If it's the y, then that is your y coordinate of the vertex, and if you graph the parabola with vertex -1, 2, it's not right. It's partially right, but it's not right. The only other thing I need to know is, I've already determined this opens sideways. Is it left or right? Leading coefficient's negative means it opens to the left. Any questions? All right. 2 more 6 minutes. We can do it. Number 48, why can that not possibly be a circle? Only one variable squared. And they don't, actually, you couldn't even say they don't have the same coefficient because you don't have a y squared to look at its coefficient. Now that I think about it, only one variable is squared, so it's definitely a parabola. And it's the x that's squared. Is that the new kind or the old kind? Y equals x squared is the old kind. That has a vertical axis. But again, these examples are in ascending order of difficulty. I not only need to solve for the first degree variable, but I'm going to have to complete the square on the x's to get it in that form of a perfect square trinomial, to factor it into one parenthesis with a square outside. I'm going to group those x's and move everything else to the right, and then complete the square on my x's. What would I have to add inside that parentheses to complete the square on the x's? Half of 6 is 3. 3 squared is 9. Add 9 to the left. You also have to add 9 to the right. Now, I'm going to go ahead and add the 4y and subtract the 1, and then add the 9. I got the x's by themselves, then completed the square. Whatever I added to the left, I made sure I added the same thing to the right. What does that left-hand side factor into? X plus 3 squared. What does that right-hand side clean up to be? 4y plus 8. Now there's two things you can do here, and if you do one of them correctly, you'll have the right answer. But notice the difference between the right-hand side of 48 and the right-hand side of 42. 42 had a 16 factored out, so I divided both sides by 16. This doesn't have anything factored out. Either I could factor out the 4 and then divide by it, or I could just subtract the 8 and then divide by 4. Doesn't matter which one of those two things you do. On this one, my preference would be to subtract the 8 from both sides. And then to divide both sides by 4. When you divide both sides by 4, make sure you divide every term by 4. What is the vertex of that parabola? Yep, and that is in the correct order because the 3 is with the x. So it's the x coordinate of the vertex. 3, negative 2, and this vertical parabola opens up. Any questions? All right. The last one is actually a little bit easier than 48. I know it's a parabola because only one variable is squared. I know that it opens horizontally because the y is squared. So I'm just going to write horizontal parabola. But it's not in vertex form where I can look at it and see the vertex. I'm going to have to complete the square on the y's. And when
Your conference is scheduled to end in 2 minutes.
I'm going to have to move that x over to the right-hand side. What would I have to add to complete the square on the y's? Half of 2 is 1. If I add 1 to the left, I have to add 1 to the right. That left-hand side factors into y plus 1 squared. And then what's my last step? Somebody say solve for x. Yes, get the x by itself. Just subtract 1 from both sides. So this is a horizontal parabola, which opens in what direction? Leading coefficient in front of that parentheses is a positive 1, so it opens to the right and has the vertex what? And it really doesn't matter in what order you write, -1, -1. It's pretty much the same either way. Whoops, doggone it. Seems like I end every video with a mistake. That's just annoying. On the bright side, either I catch it or you catch it. Somebody catches it.